All right, today we're going to talk about graphing logarithmic functions. Hopefully by the end of today's lesson, all right, number one, you'll understand that logarithmic functions are the inverse of exponential functions, which we should already know. Number two, you'll know how to graph logarithmic functions, looking at some of the key features of the graph. All right. Now, this is what I would consider the parent logarithmic function. All right. Anytime our a value is greater than 1, I said parent, that's probably not the right word. This particular logarithmic function would be compared to the growth function of the exponential function. So, anyway, why is that? Because our base, which is a in this problem, I could put a b there if I wanted to. The base is greater than 1. All right? Now, if you look over here at our wall of functions, we see that whenever our base for an exponential growth function is greater than 1, that it makes it grow. So here our base is greater than 1. So if I were to convert this to exponential notation, what I would have would be base a to the exponent y equals x. All right, that's the exponential form of this logarithmic function. This is one of the things we had to do in our test when we solved logarithms. All right, we had to be able to convert between exponential and logarithmic form. Well, whenever I'm dealing with exponential to log or log to exponential or any other inverse functions, to go from one to the other, I simply swap the x and the y values. Do y'all remember doing that? When we wrote the inverse of a function, we found the inverse, we swapped the x and the y, and then we solved for y. Y'all remember doing that? So if I swap x and y right here, this is what I get. I get a to the x equals y. Well, now I've got the exponential function. The exponential function, a to the x equals y, is the inverse of the log of base a of x. I can write it like this. I can say f to the negative 1 of x equals a to the x. Let me say that instead. All right, so if this was initially f of x, then f inverse of x is a to the x. Instead of log base a of x, a to the x. Now, I said all of that to say, when we graph the exponential growth function, it looks like this. Notice the asymptote is the x-axis. But over here, for the inverse, the logarithm is the inverse of the exponential function. Notice now my asymptote is the y-axis. Over here, for our parent growth function, we had I call it the shift point, a shift point that's 1 unit above the asymptote on the y-axis, right? Well, over here, we have a shift point that's 1 unit to the right of the asymptote, and it happens to be on the x-axis. So everything's the opposite of the way it was with exponentials. Okay? Now, this is like what you would say is the inverse of the growth function. Let's take a look at the inverse of the decay function. So, I still have the asymptote as the y-axis. I'm still going to have a point that's 1 unit to the right on that x-axis, but this time my curve is going to do this. All right? This is the function f of x equals log base a of x, where a is between 0 and 1. In other words, a fraction, like 1/2 or whatever. And this is the inverse of the decay function of exponentials. All right? The exponential decay function would do this. All right? Notice how they look similar, but the asymptote's different. They kind of look just like each other, don't they? But the asymptote is different. Now, that's just a little characteristic that happens. Oh, I did the wrong thing. They shouldn't look like each other. Sorry. Oops, nobody corrected me. This is the decay function. All right. All right, so that's the decay function. This is the inverse of that decay function. All right, when my base value of the log is between 0 and 1. In other words, like fraction like 1/4 or whatever. All right, so I told you all that stuff now so that we can graph some of these basic things. All right, graph log base 6 of x. Now, here's the thing. That base of 6 is not going to change the way this graph looks very much compared to some other base. Except that it tells us for sure that this is the inverse of a growth function. Now, when I graph this, first of all, I'm going to graph the asymptote like I always do. So my asymptote is the y-axis because that's your normal asymptote if I have not shifted. Now, since I've got a vertical asymptote, the shifts are going to be determined by whatever is being added or subtracted to the x. All right? So I'm going to shift this thing left and right, or horizontally, if you will. There is no shift for this one because it's just x. Now, I've got a shift point that is 1 unit to the right of that asymptote on the x-axis. So, notice there's nothing out here to the right that would indicate a vertical shift up or down. So I've got a point right here, and I know that this type of log function goes down in this way. Okay? It's going to go up very slowly over here. Kind of flattens out a little bit, but it never really, it's never flat, but it's slow. It grows very slowly. All right? Now, what if I had y equals log base 3 x plus 1 and then a minus 3 out here to the right? All right, what is this going to do? Well, let's see. First of all, again, log base 3, it's not going to be a whole lot different than log base 6 or log base 10 even. All right? But that x plus 1 is significant. What is that plus 1 telling us to do? Does it tell us to shift to the right or to the left? To the left. Because remember, we always go opposite when it comes to the horizontal shifts. So we're going to go to the left 1 unit and put our asymptote. All right. We would normally have a point 1 unit to the right. So that would be here at the origin, right? But I've got this negative 3. So that negative 3 tells me not only do I have to go to the right 1, but I also have to go down 3 to get what I call the shift point. All right. Now I've got that point. And so the curve does this. Okay, again, it's never going to touch that asymptote. It's going to grow very slowly over here on the right. All right, let's do another one. So if I had y equals log base 1/2 of x minus 2 plus 5. Okay, let's do it. All right, so I'm going to go ahead and put some tick marks here. All right, now my asymptote is which direction? Left or right? Right 2. Okay. My shift point would normally be 1 unit to the right. But I've got this plus 5 here, so what does that tell me to do? Go up 5. Right 1, up 5. Put your point. Now, this happens to be the inverse of the decay function because the base is 1/2. So instead of going like this, it would do the opposite. It would do like this. And you got to know that. Okay? You've got to know what it's supposed to look like. All right, so I've said all that, done these examples in order for us to do some practice. So we're going to go to the calculator now. And pause this for a second. Okay, class, write down these two functions, and we're going to graph these functions on the graphing calculator, but I'm going to have to leave this screen. So you'll need to write them down so we can refer back to them. All right. So, the first function that we wrote down